Since this is a lightning talk, I'm going to tell you about a whole bunch of data we have, but point out that some of it is in this recent paper that just came out in JGR Biogeosciences, so you can find out a lot more there. But we recently started to think about ponds, marsh ponds in my lab, in part because they can be really prominent features of the landscape, but they are rarely incorporated into assessments of ecosystem level functioning. And so we've been doing this up at the Plum Island Ecosystems LTER, and this is an aerial view of that site. And on the right-hand side here, these are the LiDAR data from that same section of marsh. And so the dark blue, this is high marsh, the red is low marsh, and all of these bright blue dots, these are permanently inundated but isolated ponds. And in this system, they occupy about 8% of the land cover, but in other systems, so like the Blackwater marshes in Maryland, they can be up to 60% of the land cover. So they can be really prominent features of the landscape, but we really have no idea about their biogeochemical functioning. And so what we wanted to do in this study is start to look at the biogeochemistry of these ponds over different tidal stages. So we looked at both flushing periods and isolated periods, and through summer and fall. And we collected a ton of data, but I'm just going to focus on our metabolism and soil core data here. And so in the surface waters, we measured metabolism using a diel oxygen flux. And so we estimated from those oxygen cycles gross production, net production, and respiration. I'm just going to focus on respiration here in the middle. And so our units are in milligrams of oxygen per liter per day. And so a positive number here means the system's net autotrophic, and a negative number means it's net heterotrophic. And we looked at these rates in 3 different ponds, and we creatively named them pond 1, 2, and 3. And pond 1, in these gray bars, had the highest plant biomass of all 3 ponds. And it was net autotrophic in the summer and the fall, even though rates slowed a little bit. Pond 3 had our most depauperate plant communities, and it was net heterotrophic. And pond 2 had our intermediate plant communities, and it switched from autotrophy in the summer to heterotrophy in the fall. And the reason why I'm showing you these data is to show you the sort of the diversity of metabolism that we're seeing in these ponds, it's hard to predict. And so we also looked at processes in the sediments, and so we looked at DIC, diffusive flux, sulfate, and ammonia. And a positive number means that there's a flux from the sediments to the water column, and a negative number means that there's a flux from the water column into the sediments. And so we see respiration in all 3 ponds, and that these respiration rates really differ. We also see some evidence of sulfide oxidation going on. So there's probably a lot of diversity in metabolism that we're just not capturing. So what we really want to know is whether or not respiration can account for the formation and expansion of ponds. And so we did this by combining some sediment core data with our respiration data. And so in the ponds, we measured sediment accretion rates using cesium-137 and lead-210, and we got pretty comparable rates. But the important thing is that these rates are a lot slower than rates that are in the accretion rates in the marsh. And so what we wanted to know is sort of a first order is if respiration can account for the difference between the pond accretion rates and the marsh accretion rates. And for that to happen, we have to have a respiration rate of about 8 to 19 millimoles of carbon per meter squared per day. And that agrees fairly well with what we measured in the surface waters and the sediments. So respiration is a very plausible mechanism for pond formation and expansion. The next thing we wanted to do was think about the role of ponds in the greater ecosystem. And so generally when we think about production and respiration in the marsh, we think about chamber incubations. And so what we wanted to do was create land cover-based estimates of net production and respiration. And so we took rates of respiration and production based just on soil and grasses in the marsh and included or combined it with air rates of production and respiration in the ponds based on the land cover here. And what we found is that these integrated rates, so net production is 8 to 16% lower than rates based on grasses and soils alone. And ecosystem respiration is about 3 to 10% lower based on grasses and soils alone. So accounting for ponds means that we are currently, if we're not accounting for ponds, we're currently overestimating both rates of ecosystem production and respiration. And so some of our take-homes are here, and just that the ponds are really heterogeneous, and that organic matter decomposition probably accounts for a lot of their formation expansion.